Good evening, my YouTube viewers. It is Crystal here. I just wanted to make another code review for you because I've been practicing on TensorFlow, and this title says Lions or Cheetahs TF-CNN, but really it's a pre-trained model. It is a CNN, but it's a pre-trained model because I'm practicing. And so because I'm new and I have to practice code from other people, I borrowed this code and it's a pre-trained model. So I got it from the Lions or Cheetahs image classification. So if you want to know what it is, it's this data set right here. And so what we're going to do now is we're going to go ahead and do the code review. I did the code review in Kaggle, Jupyter Notebook, and so I have made it public, and I will leave a link to the notebook in the description box down below, so you can look at the code if you want to. And I did have to borrow somebody's code because I'm new and I'm practicing, but I did modify it, so it's not strictly their code. It's a little bit of their code and a little bit of my code, because while I'm still learning how to use TensorFlow, I have to use the code of other people so I can learn. So I've got it set up on a GPU as well. I didn't want to use a TPU because TPUs are in a waiting list. And since the TPUs are in a waiting list, GPUs are easier to use. So I'm using a GPU, which is a graphics processing unit. So we look on the problem statement. It said this data set contains images of lions and cheetahs. The task is to classify them as being lions or cheetahs. So we're into visual. And then after we have created the program, then what you want to do is you want to import the libraries. So I started out importing the libraries that I knew I was going to need throughout the program, as being NumPy as NP, which creates your NumPy arrays and carries out your numeric computations, and import pandas as PD, which creates your data frames in your series and does your data processing. Import OS, which is operating system, goes into the operating system and retrieves the files. Import matplotlib.pyplot as PLT, that's your graphics, and import Seaborn as SNS, and that's also your statistical graphics. So those are just the things that I always import automatically whenever I create a file. So we're going to load the files, and we're going to use OS to retrieve all of the files. So we've got 100 files that are lions and 100 files that are cheetahs. So you can see all of that. Okay, and then now what we're going to do is we've got to set the dataset path. So import path live, and then data dir equals the Kaggle input lions or cheetahs image classification images. Data dir equals path live dot path data dir, and then you can see your data dir. Okay. So, and then we create a directory for cheetahs, and we create a directory for lions, and then our print length of cheetahs is 100 and length of lions is 100. So what that means is there's 100 images of cheetahs and 100 images of lions. and then we create some more. We import some more matplotlib.image as img and import pil.image as image image. And then what we're doing now is we are going to randomly select a picture, because the way it had been done previously was they just said, we'll look at picture number 0, but that wasn't very interesting to me. So what I wanted to do is I wanted to do a random creation. So every time you run the program, you're going to get a different random number. So we created a random number, and Cheetahs image equals img.imread, Cheetahs rand cheetah, Lions image equals img.imread, Lions rand lion. And then so the for Cheetahs it was number 24, and for Lions it was number 25. So here you can see randomly selected picture of a cheetah and a randomly selected picture of a lion, because I just thought it was boring always checking picture number 0. I thought, well, every time you run the program up, you'll get a different picture and it'll be a little bit interesting. So now what we do is we define the images and we define the labels. So df images equals, it's a dictionary, it creates a dictionary. So Cheetahs is cheetahs and Lions is lions. And the labels is another dictionary. Cheetahs is 0 and Lions is 1. So now what we do is we import CB2. That's a library for computer vision. So img equals cb2.imread, string df images cheetahs rand cheetah, and then it converts it to a numerical array, and then we ask for the shape. So the shape is row number 683, 1024 columns, and it has a depth of 3. It's 3 dimensions. Now what we do is we define our x and our y. So x is your independent variable and y is your dependent variable. For label images and df images.items, for images and images, img equals cb2.imread, string image, resize image equals cb2.resize img 224, 224, and then x.append resize image, y.append df labels label. And then so we print length of x and length of y, and it's 200 and 200. So the length of x is 200, the length of y is 200. Now what we're going to do is we're going to normalize x. So in x equals np.array x equals x divided by 255, and y equals np array y. So you divide x by 255 because it has pixels from 0 to 256, and then so if you divide it by 255, then what it will do is it will make all the cell values between 0 and 1. So now what we're going to do is we're going to split the data set up into training, validation, and testing sets. And so we're going to do it twice. So xtrain, xtestval, ytrain, ytestval equals train test split, xy, train size equals 0.8, random state equals 42. And then xtest, xval, ytest, equals train test split, xtestval, ytestval, random state 42. And then we check the shapes of all of these things. So xtrain shape is 160 by 224 by 224 by 3. Xval shape is 10 by 224 by 224 by 3. Xtest shape is 30 by 224 by 224 by 3. Ytrain shape is 160. Yval shape is 10, and ytest shape is 30. So now what we're going to do is we're going to define the model, or we're going to import the model. And then so it's on TensorFlow. So we have to import TensorFlow as TF. From TensorFlow, import Keras. Import TensorFlow hub as hub. From Keras.callbacks, import model checkpoint early stopping. And then we print the version. So the version is 2.11. And now what we're doing is we're importing our pre-trained model, which is MobileNet, and then it gives you the web address for MobileNet, and then that's your model, that's your pre-trained model. MobileNet equals hub.keras_layer, MobileNet, input shape 224 by 224 by 3, trainable equals false. And now what we do is we define our model. So num label equals len np unique y. So that tells you the number of labels, and there's 2 labels, either a 0 or a 1. That's the number of unique values. Model equals keras.sequential. Then MobileNet is the first line of the model. Keras.layers.dropout equals 0.2. Keras.layers.dense equals num label, and that's 2 because you have a 0 and a 1. And then we look at the model summary, and then so the first line of the model, it gives you a lot of parameters. The dropout gives you 0 parameters, and then the last line of the model is 2,562. So now what we do is we compile the model. The optimizer is atom. Loss equals tf.keras.losses. Sparse categorical cross entropy from logics equals true. Metrics equals ACC. Then we put in early stopping equals early stopping. Monitor equals val loss. Mode equals min. Patience equals 25. Verbose equals 1. And then we check MC equals model checkpoint, which is best model.h5. Monitor equals val loss. Mode equals min. And say best only equals true. And then now what we're going to do is we're going to fit the model. History equals model.fit, xtrain, ytrain. Epochs equals 100. Validation equals xval, yval. Callbacks equals early stopping and MC. So we go through all our epochs. And it stopped at 52. So although we set it up for 100 epochs, it stopped at 52. Now we make predictions on xtest. So ypred equals model.xtest. Batch equals 64. Verbose equals 1. Ypred bool equals np.argmax. Ypred axis equals 1. Then ypred bool is going to be either a 0 or a 1. Then we evaluate the model. So we check the accuracy score. The accuracy score is 86.6667%. And then here we use TensorFlow's evaluate, and you get the same figure, 80.8667. Now we put it on a classification report, so you can see the goodness of fit of the model because it checks precision, recall, F1 score, and support. Now we put it on a confusion matrix. So we had 12 zeros and 3 ones that should have been 0. And we had 14 ones and 1 0 that should have been a 1. And now what we do is we create a data frame where we check the actual values against the predicted values. So you can see that the actual values against the predicted values. And then we've got, I didn't do this, the guy that did the program did this, but he's checking training and evaluation accuracy from every epoch. And then he also did training and evaluation loss for every epoch. So I didn't do that. The guy that wrote the program did that. But I just left